Have you ever looked up at the night sky and felt a sense of profound wonder? Imagine an object out there so powerful, so dense, that it warps the very fabric of the cosmos around it. This is not science fiction. It is a fundamental reality of our universe. These cosmic enigmas are called black holes. They are some of the most mysterious and misunderstood objects known to science. They defy our everyday intuition. A black hole is simply a region of space-time where gravity is so overwhelmingly strong that nothing, absolutely nothing, can escape its grasp. Not a planet, not a star, not even light itself. The idea of a black hole can feel intimidating. People often picture them as cosmic vacuum cleaners, roaming and gobbling up everything. But the reality is more elegant and more interesting. They are not hungry monsters, but a natural consequence of physics, specifically Einstein's general relativity. They are the quiet final state for some massive stars. Understanding them reveals the ultimate limits of gravity, space, and time. They are nature's ultimate expression of density. So, what are we really talking about? Black holes are not born in peace. Their creation is one of the most spectacular events in the cosmos. It all begins with a star. Not our gentle sun, but a true giant, tens of times more massive. For millions of years it fuses lighter elements into heavier ones in a scorching core. Outward pressure balances gravity, until the fuel runs out and the furnace dies. Gravity wins catastrophically. The implosion triggers a titanic supernova, blasting the outer layers into space, seeding the galaxy with heavy elements. If the core is massive enough, it collapses into a stellar mass black hole with masses from a few to a few dozen suns. At the heart of most large galaxies, including our Milky Way, lurks a supermassive black hole. True titans, weighing millions or even billions of suns. Ours is about 4 million. They may start from early colossal gas clouds and grow by consuming stars, gas, and even other black holes. As pairs spiral together for eons, their collision unleashes gravitational waves and forms an even larger black hole. Accretion and mergers let these behemoths dominate and sculpt their galactic centers. Every black hole is defined by a boundary. It is not a surface you can touch. It is a one-way door into the unknown, the event horizon. As mass is compressed, gravity intensifies. For a black hole, the escape velocity exceeds the speed of light. Since nothing can outrun light, anything crossing the horizon is trapped forever, the ultimate point of no return. Imagine a powerful waterfall. Far upstream, the current is gentle and a boat can turn around. Closer to the edge, the current grows stronger. There is a specific line where no engine could push the boat back. Cross it, and its fate is sealed. That line is the event horizon. From afar, your clock appears to tick slower and redder near the horizon. Gravitational time dilation, as Einstein predicted. But to you, time feels normal. You cross the horizon smoothly, noticing no bump at all. Inside, space-time is so warped that all possible futures lead inward. It's not about thrust anymore. Space itself flows inward faster than you can move outward. At the center lies the singularity, where our current physics breaks down. A swift, final journey into a cosmic mystery. Black holes are far more than curiosities. They are laboratories for extreme physics. We cannot see them directly, so we observe their effects like cosmic detectives. At our galaxy's core, stars orbit a dark point at incredible speeds. Ironclad evidence for Sagittarius A. From this dance, we calculate the black hole's mass with stunning precision, testing gravity in extremes. Black holes are not completely dark. Gas, dust, and stellar debris form a superheated accretion disk that blazes from radio to X-rays. Telescopes map these emissions, revealing how matter behaves under extreme gravity. In 2019, the Event Horizon Telescope captured the first image of a black hole's shadow in galaxy M87. A dark shadow against glowing gas, powerful confirmation of Einstein's predictions. In 2015, LIGO and Virgo first heard gravitational waves from merging black holes, an entirely new way to sense the cosmos. These signals carry precise information about the masses and spins of the black holes that created them. We are no longer just looking at the universe. We are listening to it. Black holes represent the frontier of our knowledge. They force a confrontation between general relativity and quantum mechanics. At the singularity, our equations break down, pushing the quest for quantum gravity. Stephen Hawking showed that quantum effects make black holes radiate, slowly evaporating over unimaginable times. This leads to the information paradox. Does information vanish or somehow survive? The debate continues. For all their power, black holes are stable parts of the cosmos. Earth is in no danger. The nearest known black hole is over 1,500 light-years away, and our sun will never become one. They recycle matter and anchor galaxies, keepers of secrets about stellar birth and death. They testify to the universe's complexity, elegance, and mystery. They challenge our assumptions and inspire us to look deeper. From a single dying star to a galaxy's silent heart, they connect the smallest scales to the largest. They are not just holes in space, but windows into the soul of the cosmos. When you look up, remember the invisible giants, and wonder what secrets still await.